Michael, what are you doing to that latte?
My sugar won't dissolve. I don't understand it.
You've put too much sugar in there. How long have you been stirring?
Oh, a long time.
I knew it. You won't get any more sugar in there because your drink is saturated.
Yeah?
The latte particles won't dissolve any more sugar.
Well, you know what? That doesn't matter. Because now I have a sweet dessert waiting for me at the bottom of my drink.
Ooh, nice.
Yeah.
Nice. Hi there, and welcome to Mooncom's Simple Science. This morning, I was a little sleepy, so I grabbed some instant coffee mix and some hot water, and I mixed them together, and I made myself a coffee. And then I realized I'm drinking a solution. This coffee is a solution made out of a solute and a solvent. And that's exactly what we're going to talk about in today's experiments. So let's get started. What can we use for our solute? Well, most solutes are solid. So we have some salt here. And now let's use air as our solvent. If we take a spoonful of salt, and I'll put it on the table, we can wait a few seconds and see if the air mixes with our salt solute. And then maybe we'll have an air-salt solution. So let's wait a little bit of time and see what happens. As you can see, the salt is still in its solid form, so it hasn't dissolved, and we haven't made an air-salt solution. Well, this is because air is a very bad solvent for salt. We can't make an air-salt solution. So let's try an experiment too to use a liquid solvent, such as water. So here we have some water. And just like the first experiment, I will put a spoonful of salt into our solvent, the water, and see what happens when I mix the two together. I just stir for a little bit of time. And now let's take a look at the solvent and the solute. It looks like the salt has disappeared, and it has. It's dissolved, which means that although this looks like water, it's actually a water-salt solution. But what does that mean, dissolve? Well, you see, in this cup, the water molecules are hitting against the salt molecules. So the water strikes and hits the salt molecule, and the salt molecule breaks into tiny pieces. Then the small, tiny pieces of salt hide between the water molecules, so we can't see the salt, and this is called dissolving into a solution. Now, what would happen if we added a boatload of salt? Can we expect that a great deal of salt will dissolve into the water, just like it did in experiment 2? Let's figure that out in experiment 3. So I will take several scoopfuls of salt and put it into our solvent. And let's see what happens if I stir the two together, just like we did in experiment 2. Now if we look very carefully, we can still see the salt in its solid form at the bottom of the glass. Why is that? Why hasn't this salt dissolved? Especially since we know that water is a good solvent for salt. Well, you see, this solution is now saturated, which means that there's too many salt molecules for every one molecule of water. That's a definition of saturated. What have we learned? First, that in order to make a solution, you have to dissolve a solute into a solvent. Second, that in order to dissolve, a solute must first break apart into tiny pieces. And third, that a saturated solution can no longer hold any more solute. So the next time you're tired in the morning, just get some instant coffee mix. But remember that you're drinking a solution.